we had seen that with introduction of division, there was a problem of representation too. Every time I could not take two integers, divide them and get a result as an integer. So integer was not giving me a result every time when I used to divide two integers. So let's say 7 by 2. If I divide these two integers, I can see that if I divide this length 7 into two equal parts, that is 7 by 2, the length of each part is greater than 3 but less than 4, and there was no integer to represent this length of each part. Also I can see that as if I see number of 2's that fit into 7, then the 2's do not perfectly fit into 7. They do not evenly fit into 7, and hence there was no integer that could represent this 7 divided by 2. So I can say that integers are not closed under division. Now mathematicians wanted a way out. They wanted something that could close this operation of division. So ancient people came up with the concept of fractions. The earliest known fractions historically were the unit fractions, which were later called as simple fractions also. Now unit fractions were written as 1 over any natural number, and this natural number was called as denominator. So it could be 1 by 2, 1 by 4, 1 by 8. So you can, the denominator, which is the number at the down, could be any natural number. 2, 3, 4, 8, any natural number. Now the idea was simple. Dividing a unit, that is one unit, into some number of equal parts. So dividing 1, that is this one unit, into 2 parts. Dividing this one unit into 4 parts. 1, 2, 3, 4. Again, dividing this one unit into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So that is how the idea of unit fractions came about. But what does this actually represent? What is 1 by 2 actually mean? What does 1 by 4 mean? What is this 1 by 8? So 1 by 2 actually represents each part. So if I divide this into 2 equal parts, I divide this unit 1 into 2 equal parts, I get this, which is half. Similarly, if I am dividing this one unit into 4 equal parts, 1/4 gives me each part. That is this part. So 4 equal parts, 4 such parts would make up this whole unit. Similarly, what is 1 by 8 giving me? 1 by 8 again gives me one part, which is one part of these 8 parts which are equal. So 8 such parts would make up this whole. Now it is not necessary that we divide 1 by 2, 1 by 4. This unit could be anything. Let's say if I say 1/3 of a pizza, then this pizza acts as one unit and I divide it into 3 equal parts. One unit divided by 3 equal parts, and 1/3 actually represents this equal part of a pizza. One equal part of this pizza when divided into 3 equal parts. Similarly, if I say 1/3 of 6 pizzas, then these 6 pizzas together make one unit, that is one unit, and I divide this one unit into 3 equal parts. So let me do that. I divide it into 3 equal parts. One part, second part, third part. So this 1/3 actually gives me the one of those equal parts. That is this. So one equal part is this. 3 such parts would make up this entire unit, which is unit which has 6 pizzas. So now, can you answer this question? Which of these diagrams does not represent 1 by 4? So to show 1 by 4, I need 4 equal parts, and one of those 4 equal parts should be shaded. So I have here 4 equal parts and one of them is shaded. So this shows 1 by 4. This shows 1 by 4. Again, 1, 2, 3, 4. 4 equal parts, one being colored. I have 1 by 4 here also. Again, 4 equal parts. 1 is colored, 1 by 4 here also. So all these 3 show 1 by 4. Let's move on to this. Is it divided into 4 equal parts? Clearly you can see that this is much longer apart than this. They are not divided into equal parts, and hence this does not show 1 by 4. This means 1 by 4 means that the diagram, this entire unit 1 should be divided into 4 equal parts. But this is not divided into 4 equal parts, hence is not 1 by 4. Now let's visualize fractions on a number line. So fraction was 1 over any natural number. Let's say 2. So this 2, this denominator actually tells me the number of divisions in this unit. So I have a unit length which is 0 to 1, and this denominator tells me the number of divisions in that unit length. So to represent half, in this one unit, I would make 2 divisions. And I would say that this is 1 by 2. What is 1 by 2 telling me? On the whole, 1 by 2 tells me the length of this each part. This length is half. Again, this length is also 1 by 2, which is half. So this is what I get. Half is telling me, this fraction on the whole is telling me the length of each equal part. Whereas this 2 tells me, the denominator 2 is telling me, is indicating the number of parts I should divide my unit length into. Let's say 1 by 7. The denominator tells me that I have to divide the unit length into 7 equal parts. So this is the unit length. I divide it into 7 equal parts. 1, 2, 3, 4, 5, 6, 7. So I have 7 equal parts. Now 1 by 7 represents the length of one of those equal parts. So this one part is 1 by 7. Now let us look at this. We have this one block. Now if I multiply it by 3, or if I add this one block repeatedly 3 times, I get 3 blocks. That is, if I multiply this by 3, I get 3 blocks. We had seen that division was a way of reversing back multiplication. So what I can say is, if I want to go back from here to this one block, I need to divide by 3. So if I divide these 3 blocks by 3, I would get back 1. That is one way of looking at it. Now let's look at fractions. I have these 3 parts. If I take 1/3 of it, what would I get? So these 3 parts, if I divide it into 3 equal parts, each part would get 1 block. So if I take 1/3 of this, I get back to 1 block. So what I see is that fractions is also taking me to 1 block, and division is also taking me back to 1 block. What I can say is that division and fractions are one as the same thing. They're the same thing. Writing 1 by 3 is same as this fraction 1 by 3 is same as writing 1 divided by 3, or 1 over 3, 1 by 3. So division can be read as fraction only. So this divided by 3, 1 divided by 3, 1 by 3, fraction, all are the same thing. 1 by 3, 1 divided by 3, 1 over 3. So what we get from here is that division and fraction are the same thing.